we're given two position vectors of two individual masses. So instead, we're going to find out what the position vector is of the entire system where both particles have equal masses. So to differentiate from the little r, we're going to use big R with respect to t, which is going to be the position vector of the whole system. And that's r1 t dot m1 plus r2 t dot m2, and we're going to divide all of it by the addition of both the masses. So position vector times the mass plus the position vector times the mass divided by both the masses. So we know that m1 equals m2, so we can simplify this to have m r1t plus r2t divided by 2m. So let's plug in both the position vectors given into this equation. So that is the general equation. You've got to use that every single time. So let's plug that in. So m on the outside, I'm going to get cos ti plus sine tj plus t squared k minus cos ti minus sine tj plus t squared k. And I'm just going to look at the numerator, so this numerator for now. Cos ti minus cos ti, that cancels. Plus sine tj minus sine tj cancels. So we've got a t squared k plus t squared k. So that's now going to be m 2 t squared k divided by, and we've got a 2m in the denominator. So let's do r t. 2's are going to cancel, m's are going to cancel, and therefore we're going to get our answer of r t equals t squared k. And you've now calculated the position vector of the entire system.